Welcome everyone. Today we're going to be going through questions 20 to 30 of the Intermediate 2006 Australian Maths Competition. So question 20, we have 450 grams of salt and flour mix. How many grams of flour should I add to reduce the percentage of salt in the mixture to 90% of what it was? So let S equal the grams of salt and F equal the grams of flour. So the initial percentage of salt is just S over 450. And then when you add the flour, then depending how much you add, so x, it's now going to be S divided by 450 plus x. And then we set the new to 90% of the initial. So then S on 450 plus x equals 0.9 times S on 450. We can cross multiply and then simplify this, and then we're going to get x equals 50. The answer is A. Question 21. How many positive integers less than 72 have the property that the highest common factor of the number and 72 is equal to 1? So if you work out the prime factorization of 72, you get 2 cubed times 3 squared. So to work out how many integers have a highest common factor of itself and 72 equal to 1, you do 71, and then you can take all the multiples of 2 and all the multiples of 3, and then add the multiples of 6, or which is the multiples of 2 and 3. So if you count all of them up, you're going to get 71, take 35, take 23 plus 11, and that gives you 24. So the answer is E. Question 22. The 9 squares of a 3x3 grid painted on a wall are to be colored red, white, and blue so that no row or column contains squares of the same color. One such pattern is shown in the diagram. How many different patterns can be made? So no row or column can have the same color. If we just look at it row by row, then in the first row, 3 factorial, or 3 times 2 times 1 is 6. So we have 6 ways of choosing the top row. Then to have no colors the same, we can have 2 choices in the second row, and then the third row is determined. So it's just 6 times 2, giving us D, 12. Question 23. 5 bales of hay are to be weighed 2 at a time in all possible combinations. So there's 10 combinations. The weight in kilograms are as follows, and we have to work out the weight of the heaviest bale. So I'm going to call all the barrels A to E, and I'll say, going in ascending order, A is the lightest, E is the heaviest, so we need to work out E. From the 2 lightest barrels, so A and B, we know that they will add up to the lightest weight, so 110. Same story for the heaviest, D plus E is going to give us 121. Now we can do the lightest and third lightest. It's going to give us 112 over here, and the same for the heaviest will give us 120. So since each barrel is weighed with every other barrel, and there's 5 barrels, so they're weighed with 4 others, if we add all of these up, then this should be 4 times that will equal the sum of all the weights given here. And all of these added up divided by 4 gives us 289. So with this information, we can solve for E with simultaneous equations. We've rewritten them here and labeled them 1, 2, 3, 4, 5. So if we sub 1 into 5, we get this. A plus B is 110. Then we can sub in 4, and then 2, and then solving this, the e's cancel, and we're going to get e equals 62, giving us the answer e. Question 24. The squares PQRS and LMNO have sides of 1 meter and are initially placed so that the side SR touches LM as shown. The square PQRS is rotated about R until Q coincides with N. The square is then rotated about Q until P coincides with O. It is then rotated about P until S coincides with L, and then finally rotated about S until R coincides with M. And the square is now back to its original position. The length in meters of a path traced out by the point P in these rotations is, and then you have the answer options. I've gone ahead and done a diagram, and I've also included some animations. So here's point P. So first it's going to travel along this semicircle. Then it's going to travel along the next semicircle. And then here it's going to stay in the same spot. And then it's going to travel one more semicircle. So this radius of this circle is root 2. So this arc's length is root 2 pi. This circle's radius is 1, and same as this one. So the length of these arcs is just pi. And if you add them all up and factor out pi, you're going to get pi times 2 plus the square root of 2, giving us the answer A. Question 25. The vertices of a cube are labeled with one of the integers 1 to 8. A face sum is the sum of the labels of the 4 vertices on a face of a cube. What is the maximum number of equal face sums in any of these labelings? So each cube is going to have 6 faces. So it's going to have 6 face sums. And it's actually possible to do one with 6 face sums. So the maximum is 6. Question 26. We have some series of arithmetic sums, and we have to work out what is the value of P plus Q. So I've included the arithmetic series formula, the formula for the sum on the right here. So we can use that over here. Now n is the number of terms being added. So since we're adding from 1 to n, the number of terms is going to be the last term plus 1 divided by 2. So if we replace that in, these are actually the same thing being times together, so we can square these. And now this is, you have it in the form a squared plus b squared equals c squared. And the 5, 12, 13 right triangle is well known. So you can replace these with 5 and 12, and then solve for p and q. And you're going to get p plus q equals 32. Question 27. Each of the students in the class writes a different 2-digit number on the whiteboard. The teacher claims that no matter what the students write, there will be at least 3 numbers on the whiteboard whose digits have the same sum. What is the smallest number of students in the class for the teacher to be correct? So there are 18 possible sums, 1 through to 18. And the idea to find the largest amount of numbers is to do 2 of each with the same sum. So 18 times 2 is 36. Except for the fact that there's only one way to get a sum of 1 and 18. So 10 gives you the sum of 1, and 99 gives you the sum of 18. So there's only one way to do both of those. So we have to subtract 2. So the largest without 3 of the same is 34. So the largest to guarantee 3 of the same is going to be 35. Question 28. In a quadrilateral PQRS, X is a point on QR and Y is a point on PS. One circle touches all 4 sides of the quadrilateral PQXY, and another circle touches all 4 sides of XRSY. If PQ is 10, QR is 20, RS is 14, and PS equals 26, what is the length of XY? So here, on the right, I've gone and drawn this up, and on the left, I have just a picture demonstrating that the tangents from an external point are equal. And using this, we can get that PQ plus XY equals XQ plus PY, and similarly, RS plus XY equals XR plus YS. So if we substitute the numbers in for those, we're going to get 10 plus xy equals qx plus py, 14 plus xy equals ys plus xr. If we add those two equations together, we're going to get 2xy equals qx plus xr plus py plus ys minus 24. And then qx plus xr is just the same as qr. And for py plus ys, it's the same as p to s. So we can sub in 20 and 26, and then solve xy equals 11 centimeters. Question 29. In a regular polygon, there are 2 diagonals such that the angle between them is 50 degrees. What is the smallest number of sides of the polygon for which this is possible? So for the angles between the 2 diagonals to be 50 degrees, there must be 2 vertices that divide the perimeter in a ratio of 50 to 130. Then there must exist an integer a such that a on n take a equals 50 on 130. This becomes 18a equals 5n, so the smallest solution is a equals 5 and n equals 18. So 18 is our answer there. Last question. The sum of n positive integers is 19. What's the maximum possible product of these numbers? So intuitively, the product of a few large numbers will be much smaller than the product of lots of smaller numbers. For example, 17 is a large number, but 17 plus 2 gives you 19, and 17 times 2 is only 34. But if we do lots of smaller numbers, so 2 plus 2 plus 2, etc., plus 3, then we're going to get a much larger product, 768. So we can improve this by replacing each 2 plus 2 plus 2, which is a product of 8, with 3 plus 3, which is a product of 9, and this gives a maximum product of 972. Thank you for watching.